Welcome back to part 2. So in the first video we talked about the segment addition postulate, which is part plus part equals whole. Now we're going to talk about a midpoint, which is a very specific kind of segment. So a midpoint is going to be a segment that is on the point, is a point on the segment that's going to divide it into two congruent parts. So congruent is a new vocab word for us. Congruent is just going to mean equal. Okay. Now the symbol for congruent is this right here. It's an equal sign with a tilde over it, or a squiggly little mark. So if B is the midpoint for our example AC over here, then I know the first part AB has to be the same as BC. So I know that the segment AB is going to be congruent or equal to the other segment BC. Okay, in geometry you also may see these tick marks. So if you see a tick mark like this, that's also a way for them to tell you that AB is congruent to BC. You may see two tick marks and two tick marks. So as long as they have the same amount of tick marks, that means they're congruent. All right, let's move on to an example. So it says, given that M is the midpoint of RS. So I'm going to draw a picture again to help us out. So my line segment endpoints are R and S. M is the midpoint. So in this picture, M is going to be in the middle. And if I want, I can go ahead and give my tick marks so I know it's the midpoint. So complete each statement. So I know RS is 10, so the whole entire thing is 10. And I'm going to try and find SM, which is one part. Now if I know they both have to be the same part, they have to be the same number. So I'm going to divide 10 in half. So 10 divided by 2 is 5. So I know each part is going to be 5. Okay? So that's how you can find the midpoint or each segment piece if you know the whole entire piece. All right, let's look at another example. I have the same picture, but some different numbers. So I have R and S as your endpoints. M is in the middle. I go ahead and put my two tick marks this time. So I know RM is 12. The first part is 12. And then I'm trying to find the second part. Okay, so again, if these pieces are congruent, they're going to be the same. So I know MS also has to be 12. And then it wants me to find the whole thing. And I can go back to segment addition postulate, part plus part. 12 plus 12 is going to be 24. Okay. So here are some examples of just straight numbers with dealing with midpoints. So again, if you know one part, you know the other part. You can double it to find the whole thing. If you know the whole thing, you can half it, etc. All right. Let me know if you have any questions on midpoint. Otherwise, you're going to check your understanding. So I want you guys to work on 7 through 10. There's some space on your paper to the right of it to show some work and write some answers. But press pause and we'll go over 7 through 10. All right, let's go over answers for 7. So first off, I drew a picture to help us out. So it says D and E are aligned with a ruler, so I drew a straight line DE. D is at the point 4.5 on the ruler, and the distance between D and E is 3.4. So I'm starting my ruler off at 4.5, and I know the distance is 3.4. So I'm trying to figure out what is point E located at. Now it could be in the positive direction or it can be in the negative direction. So that's why there's two possible answers. So first I started at 4.5 and added the distance of 3.4 to get 7.9. And I could also go the other direction over here. So I subtracted 3.4 from 4.5 to get 1.1. So that's the two possible locations for point E. On number 8, it says N is the midpoint and that Fn is 2x. And so to find the whole entire thing, you just have to double 2x. So 2x plus 2x is 4x. On number 9, it says, does a ray have a midpoint? Explain. So a ray does not have a midpoint because it goes indefinitely in one direction. So it can't be divided into two equal parts because it goes on forever and ever and ever. Lastly, number 10 wanted you to draw an example and write an example of a segment addition postulate. So here is just one of my examples. I said point B is between A and C. So you did have to say some point is between some point and some point. And then you had to give me a length of one of it, a length of another one, and a length of your whole thing. Okay, you could have had equations, you could have had numbers, doesn't matter. Just make sure your two parts added together equal your whole. And again, this was my example picture. So if you want to make sure your picture is correct, let me know and I can come check it to verify. But I just wanted you to write a segment addition postulate. All right. So let me know if you have any questions on those. Otherwise, we're going to move on. All right. So we can also use a number line to find the distance between 2 points, kind of like a ruler. So if I'm trying to find the distance between L and M, I can just physically count with this ruler. So 1, 2, 3, 4, 5, 6, 7. So that distance is 7. I could also, kind of like the front page, take the absolute value. So I can say 4 minus a negative 3. Again, you're going to always subtract to find the distance. Or you could also say negative 3, take away a 4. So again, 2 negatives make a positive. So that will become 4 plus 3, which is 7. Or negative 3 minus 4 is a negative 7. And the absolute value of a negative 7 is a positive 7. Okay, so that is 2 ways to find the distance on a number line. Again, you can count, or you can take the absolute value of the difference. So a midpoint is going to be halfway through its 2 endpoints. So if you know the coordinates of the endpoints, you can average them. So kind of like how we find our GPA to find the coordinate of the midpoint. So average means you add up your numbers and divide by how many there are. And since there are 2 endpoints, I'm going to divide by 2. So I'm going to take my first endpoint, which is at 8. I'm going to add my last endpoint, which is at 40, and then I'm going to average them or divide by the 2 numbers. So I would get 48 divided by 2, which is going to be 24. Okay. Another way of finding the midpoint is kind of meeting in the middle. So I can move once over here, move once over here, move once over here, move once over here, move again, move again, move again, move again. It met in the middle. So you can also kind of use your fingers to guess the middle as well. Okay? All right, time for practice. Hello, Belle. All right, so you guys are going to work on 13, A, B, C, and D. C and D get a little tricky, but I want to see if you can try it. So we're not going to find the middle anymore. We're going to find a third of the way. Okay? So again, try A, B, C, and D, and press pause, and we'll go over our answers. So let's go over the answers to 13A. So the distance between K and L is going to be 24. There are kind of a few ways you could do it. You could count by 3s, and so you could go 3, 6, 9, 12, 15, 18, 21, 24. Or you could have subtracted 15 minus a negative 9, which is what I did to get a positive 24. Whichever way you want. To find the coordinates of the midpoint, you could have moved one in with your finger, or we could have averaged the 2 numbers. So we could have added a negative 9 to a 15 and divided that answer by 2 to get 3. So here is the midpoint right there. Okay? All right, and then it got a little tricky. So it says point C is going to lie between points K and L. So C is somewhere in between points K and L, but it's a third of the way of KL. So first you had to figure out the distance of KL, which we already knew was 24. So then you take a third of 24, or the same thing as 24 divided by 3, which is 8. Okay? So it's 8 movement points from our starting point of a K. So I need to move 8 from K. So if K is at a negative 9 and I go 8 in the positive direction, that's the same thing as saying a negative 9 and I'm going positive 8 to give me a negative 1. So C is going to be located somewhere here at a negative 1. Okay? On D it says N is going to lie between points C and L. So now C is important and L is important. So you had to find the distance between C and an L. And so a negative 1 to a positive 15 is going to be the distance of 16 units. And so the distance of CL is 16. So now I need to take 3/4 of 16. So I'm just going to say 3/4 times 16, which is 12. So I'm now moving 12 units from point C. So I'm starting at point C, moving 12 units. So that's the same thing as saying I'm starting at a -1, moving 12 units in the positive direction. 12 minus a 1 is an 11. So L is going to be located at 11 on the number line. Okay, that is pretty tricky, finding 3/4 and 3/4, 1/3 and 3/4 of a number. So if you have a question, let me know. I can come explain it to you a better way. Otherwise, thanks for watching this part of the video on midpoints. So check in for part 3, and then we'll be finally done. So go to the next video. Woo!